Okay, continuing on with the triangles, we need to focus in on the whole idea of angles evolving on the inside of these triangles. Okay, the sum of the angles of the sums of the measures of the angles of a triangle is always going to be equal to 180 degrees. Okay, so that allows us to find missing angles whenever we're missing an angle. So in this case, we're missing this third angle. So what we would do is we would need to add 61 plus 79 to find that that's going to be equal to 140. And then we're going to take that away from 180. So 180 minus the 140 should tell us that this would be 40 degrees right here. Okay, on this one, there's really two routes that we can go with it. And that we have, we have 90 degrees here, so we could say 90 plus 38 is going to give us 128. And then we could take 128 away from 180 to find that this is equal to 52 degrees right here. Or I can, know the fact that these angles here, these acute angles, are going to be complementary. If I've got 90 degrees here and there's a total of 180 degrees in a triangle, these other two have to add up to that other missing 90 degrees. So I could take 90 minus the 38 right out of the gate and get 52 for this missing angle here as well. Okay, things are a little more complicated on this one because we've got two angles here, or two triangles, and we need to get started somewhere. So when we look at this, we know that we have 180 degrees here. So we could take 180 minus 155 to find that we would have 25 degrees here. So this would be 25 degrees. We know that we have 25 in here, so we've got two angles. We're missing our third angle here, so I could take 85 plus 25 to get 110, and then take 180 minus 110 to find that that would be 70 degrees right here. So we've taken care of our lower triangle. We had to think about supplementary angles over here to get started, but we've taken care of our lower triangle. Here we can recognize that opposite angles, these are vertical angles. I'd have 85 degrees here. I could add these two together, so I'd have 50 plus 85 would give me 135, and then 180 minus 135 is going to give me 45 degrees here. Okay, so we've made it through that. At this stage of the game, I kind of want to do this one in class. I would encourage all of you to give this your best shot, though. Recognize that you've got two parallel lines here, a transversal crossing here, a transversal crossing here, and then they intersect here. So I'm hoping you could find all of those missing angles. And this here, you've got, a right triangle here, a large right triangle, and you know that you've got 50 degrees down here. You should be able to find all the missing angles there. Okay, so I want to go ahead and finish up our information on triangles, looking at similar figures. And this really applies to not just triangles, any similar figure. But I want to point out that definition for similar figures is they have the same shape but different sizes. Okay, so we're going to be looking at and setting up a scale factor, which is basically the ratio of corresponding sides. Corresponding sides are same location, different figures though. We've kind of had that concept before. Okay, this ratio is going to help us solve missing sides here. So when I'm looking at this, I've got a small triangle here. It looks like it slid over and blew up a little bit. It's a little more complicated when you have one of these skewed and turned a little bit, but this isn't turned, so you can see that this 4 corresponds to 8, this 7 corresponds to B, and C corresponds to the 20. So in other words, we're looking at comparing the small triangle to the large triangle. We're going to set up ratios. We're going to compare the short side, the medium side, and the long side. So when I kind of set up this array here, it makes it really clear that I'm looking at equivalent ratios here, and I get all my information in the right spot. So in my small triangle, the short side is 4. In my small triangle, the medium side is 7, and then the long side is C. So I can plug those things in. In the large triangle, my small side is 8, my medium side is B, and my longest side is 20. Now, I wouldn't have to set them all up like that there. I could have just done that. I could have done just that. I could have then placed, you know, the short to the long. But putting them all on one section like that, it makes it really easy for me to stay organized and get all my information. So when I'm looking, I can see that this first ratio is the only one where I have both numbers, both the numerator and the denominator. Here I'm missing denominator, here I'm missing numerator. But I can use that tells me my scale factor. So my scale factor is right here. Okay, now when I pull that out of there, 4 over 8, everybody looks at this and say, sure, we can reduce that. 4 divided by 4 is 1/2. So my scale factor in simplified terms is 1/2. So I can set up 2 cross multiply and divide problems. 7b, this ratio should be equal to my scale factor of 1/2. And then this ratio, c over 20, should also be equal to 1/2. Okay, so I should be able to cross multiply and divide. So 7 times 2 divided by 1 tells me that b is equal to 14. When I cross multiply here, 20 times 1 divided by 2, c would be equal to 10. I'm sorry. Yep. And put all those in. Okay, going on. I'm going to draw a line here so I don't get things too confused. Going on, we've got 2 different word problems here that I'm going to encourage you to draw a picture on. At 3 p.m., a 40-foot shadow casts a tree that is 70 foot long. How long is this shadow cast by a 6-foot tall man? I think we've done this one before, but if I draw my tree here, it's 40 feet tall, 70 feet long. I can see that I have a right triangle here. And when I draw the man over here, he is 6 feet tall, and we want to know what his shadow is. So again, you can see that you've got a right triangle. So you can recognize that the height of the tree corresponds to the height of the man. The shadow of the tree corresponds to the shadow of the man. So you could set up a height to shadow ratio. Actually, I think to stay true to the whole idea of similar figures, we're going to look at the ratio between the tree compared to the man. And we're going to look at the heights, and we're going to look at the shadows. And we're going to set up this cross multiply and divide problem. So the height of the tree is 40. The height of the man is 6. The shadow of the tree is 70. And so you can cross multiply and divide. 6 times 70 is 420 divided by 40. You get 10.5. So the height of this, or I'm sorry, the length of that shadow is 10.5. Okay, looking at the next one, we've got a card with dimensions 5 by 7 is enlarged for a wall hanging. What is the length of the wall hanging if the width needs to be 20? I think a lot of times students get confused with how I've used width. I'm going to call the height, this is my height, this is my width. So we're going to look and set this up. I think it's going to be easier to draw a picture. So we have 7 by 5, and we're drawing, it's a portrait picture, and so we know that we need to find the length if the width needs to be 20. So that's going to be our 20 here, and we're trying to find this height. I realize my description here isn't super wonderful just because we could easily misinterpret which one's the width, which one's the length. So I need to set up that the 7 corresponds to the x and 5 corresponds to the 20. So these two should be equal to each other. So I'm going to say 7 times 20 and then divide by 5. So 7 times 20 is 140. divide by 5. X should be equal to 28. I know you can see other relationships. There are other ways to do this, but I'm trying to stay true to the concept of similar figures, finding the scale factor, setting corresponding sides into a ratio equal to each other.